1 to n. And we have several towers. Each tower takes some subsegment with some power. So when the monster goes from left to right, and if it is within the segment of the current cell of the motor is within the segment of the tower, it will deal that monster be damaged. And so the question is, if some monster starts in some cell and have given health, will he survive to go to the end of the segment? So this problem is not very hard. You, for each cell, you first need to calculate how much damage monster will take when he goes into that cell. So how will we do this? We can have an array delta. We say that for each tower, we add damage to delta entry point, and then we move the damage when the motor will exit the array. So basically delta is how much more or less damage monster will suffer in the next cell compared to the current cell, or more in the current cell compared to the last cell. After that we can calculate the damage. And then we can calculate cumulative damage from the end. So now for each query, for each monster, we need to compare health of that monster to the cumulative value in its entry point. If the health is bigger, the monster will survive, otherwise he will not. So any questions about this one? Okay, problem B. It has 6 values. And we needed to find whether we can write these values on the sides of the cube, so that sum of opposite values on the side of the cube is constant. So basically we need to find whether we can divide these values into 3 pairs. So that okay, let's sort these numbers. So suppose it's already sorted. Now let's see which number can be in pair with this one. if it is any other number than this one, say this one, there is always a pair that have both indices, that have one index more than this index and the other index. But basically we can look at the pair that contains this one and this way say D1 is this pair with Di and D6 is this pair with Dj. This way D1 is not more than Dj and D6 is more or equal to Di. This way, this sum is more or equal than this sum. And the equality can be achieved only if both equalities here is achieved. But this way we can exchange D6 and Dy in our sorted array, and then D1 will be paired with D6. You can prove the same way that D2 will be in pair with D5 and D3 is in pair with D4. So what we need to do to solve this problem, we need to sort array, given its input, and then just check whether these three sums are the same. Any questions? Okay, so problem C. Let's do it for now because we will have some theoretical material based on this problem. So problem D. We have a string of characters A and B of 1 to n. And then each character has some weight. We need to divide string S into two subsequences. So basically we have some indices. We have some G, then we have some U that is and also and basically we divide the string S into two subsequences that are equal such way so that the difference of weights of given string is minimal. So n is rather small, but not small enough to create all possible subsequences of length n. So what we will do is to do what is approach that's called as meet in the middle. So let's look at the first half of string S. We can trace all masks of length n so that we know which letters will belong to the T and which to the U. So there will be some so it will be like this. So if K is more or less than L, then first we need to check whether start of the strings are the same. Otherwise it's not a correct division of prefix. And then we can take the part, we can encode part of T that is longer than U, as binary strings no longer than n characters, obviously. We know the so for each mask like this, we will store what different ways we can achieve with this mask. So we will have an array of arrays. So for each mask, we will store all possible differences. Then we will do the same thing for the second half of our same thing to the second half of our string, and we will sort all this array inside string. Now, what any full division of what can we do so that when some division of the first half of array is compatible with the division of the second half of array? Only if they have the same remaining values. So we iterate for all remaining values. There is two arrays of differences. One for the first half and one for the second half. Now we need to find the one with sum that is the closest to the zero as possible. We can do this by starting with pointer in here and pointer in here. If the sum is more than zero, we will advance this pointer down. Otherwise, we will advance this pointer up. And of course, store the current sum as possible answer. Well, after we iterate through all such arrays, we will get the final answer. So this is quite usual technique that is used in many programs, especially it's bit in the middle is more widespread technique, but the one where after the bit in the middle you need to iterate to erase this way is also quite widespread. So, any questions about this problem? So, problem E. Problem E, which again has work easy. Now this time it's really rather easy. What you need to do is basically parse the input. So the input size was no more than 1,000 characters. This way you can do actually quadratic parsing. So, for example, we always parse some substring of the original text. So suppose the original text is like this. We have some substring. So first we always go, so we have some kind of operations and we have some kind of priorities of operations. So in here there is this operation that has the biggest priority. Then there is this operation that has second priority. And then there is this operation that has the smallest priority. So you go, first you go from left to right. You have a variable for balance, so you will, if so if you find this kind of operation and balance is zero, you can then separately solve the problem for different parts. Different parts, just so. Part. Yes, you will parse like parse tag. This is a function parse. Using parse tag from L to I minus 1. You will parse from I plus 1 to R. And then you will, like you parse the text, some text, so you have opening, from parse tag you have opening tag and closing tag. So the answer will be opening tag plus this result parse. Plus closing tag. So now supposedly there is a collection of several tags that are siblings. Or there is a single tag. You can understand which one is if, so after this, if L is opening bracket, then this is a collection of tags. You find the nearest closing brackets, and we will call parse from L plus 1 to next minus 1 plus parse from next plus 1 to R. Otherwise, we will call just parse tag from L to R and return opening tag to closing tag. So now how we parse single tag? So we now have some string of original text that are guaranteed to contain information about single tag. So it will be in the format name, then some dots plus 1, dot plus 2, so on. So we can just split this by dots and by this, and so returning as open tag, we just return name, ID. If there is an ID, then we will put it here. And then if there is classes, we will put it here. And as closing tag, we will just remove the return. So this is a task that required more attention, not some particular insight, but rather attention to details. Any question about this one? Okay, problem F. with several courses, each several areas of study like math, computer science, language, something like this. Each has levels from 0 to some level. And then there was some courses. That is if your level in given is more like level E, then if you pay some amount, your level in study will advance to level and we want to achieve the maximum levels in each study. So let's construct a graph. We will have a vertex for each level of each study. For each, we will have an edge of cost 0 from each, from the first level of zero level of first study to 0 level of each other study. With this weight not 0. We will have edge with weight 0 from level J of each study to level 1 down in the same study with the cost 0, because if we have level J, then by the problem statement we also have level J minus 1 and all lower levels. And then we will also add edges from where this weight, that is the amount we need to pay to take the course. So now we have graph, and if we will start in this vertex as a root, what we need to find in this graph is the minimal abundance sense of this graph, just like in yesterday's problem, if I recall correctly. So you again use Edmond's algorithm. Find this minimal weight of spine directed tree. So questions? Well, there was no questions yesterday. That must algorithm was somehow. Well, it was yesterday. It was yesterday. I checked this already. Yeah. You can probably read Wikipedia articles then if you wasn't yesterday somewhere. So, problem G. So, we have a game where the payout for win is 2. If you lose, you lose one amount of money. And also the probability of winning is some number between these two values. What we need to notice is that probability is always strictly greater than 1/3. So in the long run, you will always win. So initially, you have some amount of money, which is n. And you need to know the probability of you, whether you are going bankrupt or not. So if m is equal to 0, the answer is always 1. You already bankrupt. And then there is 2 ways to solve this problem. The magic one. They just somehow end up this formula. And the formula being that's not the interesting one. As you will always win in the long run, there is probably some value n0. If you start with n0 money, the probability of going bankrupt is less than required precision, which is so there is some value for which answer is very small, and this value should not be that big. You can calculate it, it shouldn't be more than 100. So now you may assume that answer for this value is actually 0. This way, there is, we will calculate the answer for values for 0, for 1, for the line. I have the from now somewhere on the spaces. And we want to find position of where there will be maximum number of rotations. If you stay there, and look for the first thing to notice is that if you look at our plane, it is divided into some parts by the Juliet wall. Then it doesn't matter in which point within single part Romero is standing. The rotation will be the same. So what we need to do is to divide x-axis into segments by points of intersection with 3x wall. And if there is some segment that 3x covers the wall, then we just disregard the segment because Romero can stand there. There is no more than 10 segments, and is no more than 1,000 in QAS wall. So the whole line will be divided in no more than n+1 parts. Then for each part we take any point and just calculate what is the total rotation by summing up angles and both sine angles in this case. So for each point, we create some calculate the sum divided by 3. And between all segments, we take the largest one. It is easy to see that for array going in the negative direction from the last point of intersection, and from the array going into the positive direction from the last point of intersection, the value given the problem will be continued to fit the problem is 0. That way the answer is always no less than 0. So we can take it as the initial value. And then we update it for each segment further. If you find bigger value, so questions about this one? Okay. So, just a thing to note about digital. The digital is actually just remainder of division by 9. But if the remainder is 0, the digit root will be 9 for any positive integer. And so, the digit root of multiplication of the numbers, of a product of the numbers, is digit root of the product of digit roots. So what do we have actually? In the table is some multiplication table for some values. That is from 1 to 9. So, how do we find, first we need to find the digit roots of the original numbers, and then if we have digit roots, after we recover digit roots, we can then find a number between 1 and 9 that is the same as the first number, have the same remainder, like division of 9. Number between 10 and 18 that has the same reminder as the second number, and so on. Reminder between 72 and 91, 81 for the last one. That way we will fulfill the condition that numbers are in increasing order. Okay, so first equation, whether there is a number in the table that is not divisible by 3. Divisible by 3. If you find such a number, then if there is such a number, there should be such a number on the main diagonal. So, if there is no such number on the main diagonal, we can say that there is no. This is invalid table. If there is such a number on the main diagonal, so both it's in the row and in the column I, we can first say that AI is 1 of 1, 2, 4, 5, 7, 8. We can calculate for all 6 values this way. We can then find value, look at the each row, we'll find values for all other numbers if the given number, for the given value of this number. And then we can just check whether the table is consistent. If it is consistent, we arrange to some answer. If it is not consistent for each possible value, then the answer is that there is no correct for instance, the given table is incorrect. So now suppose there is no values such that for each I and j is divisible by 3. That way, then we need to find some row, some value in the table such that I and j not divisible by 9. actually that can be. So if each value is divisible by 3, that means that there is no value in the table, no value in the original array that is one of these numbers. And so every number in the table, every A is from 8, 6, or 9. And that's why every value in the table should be 9. So the second case is all values in the table is 9. Then we can just say that all values is also 9, and then produce the answer using this. Otherwise, the answer is again that there is no such possible numbers that permitted this table. So, any questions about this? Problem L. So here we have some array. We need to unite some subsegments of this array such that array becomes a palindromic array. And also we need to pay for if we unite some number of original numbers, we need to pay depends on the amount of numbers that we unite. So let's just see how in which group the first number will lie. It will be some group. And the last number should lie in some group that has equal sum. Now we can iterate through all such possible values. And of course we shouldn't forget about the possibility that the first and the last number lies in the same group, so we need to unite all numbers. And for each such groups, we need then to calculate the best way to unite numbers in the middle, starting from A to L to A to L. But let's notice that the R is always uniquely determined by the value of L. So in total we need to calculate at most n such values, such given n divided by 2. And in each calculation we will do in more than n times. So the total solution will be like this. So let us try to write the code for this problem. Suppose there is array that initially filled by -1. Then we start with saying that we need to calculate from 0 to n, and the function calculates this. So if and just do not L. Otherwise, we have some left. Initially 0, some right. Initially 0, and we say it's a Coulomb transfer. Is for the time being weight, so weight m minus L plus 1. So the cost of uniting all of the pieces together. Then we also have this there. If so while say if some L is more than some L, we need to it's subject to some error. So we say that we add A of J minus 1. And then if some L is equal to some L and E is still less than G, we will say that plus W L minus plus W I minus L. Reverse answer, and then the return answer. Questions about this one?
What is the original size of the insert? The area minus 1?
10. Well, we probably wouldn't go by longer than the amount of this. So if you calculate some elements and sum of some just elements, and this will be more than half of the all of elements, and we won't go over there. But for simplicity, we can just create a wave set and alright, let's return to the problem D. So, what's the problem? About computing. So this problem will show us the importance of one of the most interesting data structures that are usually used in competitions, which is interval trigger. So generally speaking, suppose you have some queries. So you have some queries that are of two types, some updates. You update the value on some segments, so say from L to R, you do some operation on all the, so first off you have an array. you have operations on the array. The first operation to some update on all values from L to R. This is a update. And the second, query for some value from out to R. So, if two conditions are met, first, if so here we are asked for some operation. So suppose let's call this operation like this. So here we are asked to calculate values like this. And suppose here we apply operation to each element such that for each E from L to R. Calculate, to being able to calculate all the queries fast, we need two conditions on our operations. First, we need to be able to calculate. First, we need to. So this one should be associative. So at this almost always true for good operations. And this operation we should have, if we know some values of and we know some value x, there should be some function that produce the value of also if there is so also we need some function that given A and some operation on F of X that we can calculate, it will provide if we have this condition fulfilled, then we can use data structure called the segment or interval tree. That is, it can be defined recursively. So the segment tree for array of single element is just value. The segment tree of some array contains of segment tree of the first half of this array the segment tree of the second half of this array then value of and then some delta stored for the current applied operations to the whole of this array, some delta value. So this value is this delta. Then suppose we have some update operation. What we will do? whole array. If the current segments do not intersect current segments that lies in the segment tree, then we just ignore the separation for this segment tree. If it does intersect, and wholly contains current segment tree, then we update delta with x. And then, if it intersects, but not wholly lies inside, we will call the same recursive function for both halves of the array. But before we do that, we actually push delta down. What we mean by pushing delta down? We update left delta. Update right delta. We then update left value, right value as well. And then we say that delta is in here, delta in here, is some natural value. So let's call it by 0. And after we call both updates on both halves, we update the value, current value, as value left plus value right. So what we need to notice is that in each, so obviously segment 3 is a tree, some type of tree structure, it's binary tree actually in one segment. And let's note that in each level of this tree, we will do some operations. We will call our recursive function is no more than 4 different vertices. That is because from each level we call function down in no more than in 2 vertices, and in each vertex we call it for 2 different vertices in the level. And that is the vertices where segments where the left the L lies, and which segment L lies, and which segment the L lies. That means that the total amount of operations we've done is logarithm n operations. Now square it. So square is almost the same. So if we have from left to right, and we have current segment 3, we first update. Well, if it lies completely outside, we return 0 or natural value by plus operation. if it lies completely inside with it on value, and if it intersects, we update down once again, like this, and then call query recursively for left and right subsegment trees, and then answer will be left. So let's rewrite the solve into link code. So we have segment tree, which is the structure that contains left segment tree, right segment tree, radius, and go. Also, we are given operation plus operation of right, some kind of we are given natural value for plus, we are given natural value for multiply, and we are given some function that's given some height and x to provide some height times x. Also, it's not only height, x and length of number of elements in tree. So the operation of the then will be from into like this. If two otherwise we would have we call updates on left. German argument like this. So says that and finally query. So this is a function that main part of the segment tree. Of course, then different modifications. So, for example, let's return to Problemset. Here we have a stack. So we can change it. We have following queries. We can say that supposedly there was pop operation at a given time. Then supposedly there was insert operation at a given time. And then we want to know the last element if all operations before null that are done in a given order of times. What will we do? Here is we first condense the times. So times will go from 0 to some value k that is less than n. And we will have segment 3 on values. Initially all values are 0. Values based on time. When we push some value to replace 0 with the element we pushed. And if we open some time, then we replace the value with -1. So in each vertex of our segment 3, we will store the difference between number of positive, the amount quantity of positive numbers and quantity of -1s. And when we need to answer the query, we will look at the right part. We will have function of query left, right, balance. Oh, just balance. Okay. Now, if current balance in this vertex is more than the balance pushed down, that when everything is okay, we have some last element. We have some element in this tree that is that we can pick at. So basically, if we have this array, the next argument, if we have such array, then we go from right to left. We count the number of -1s and count the number of positive numbers. And if at some moment quantity of positive numbers is more than number of -1s, we should output the current value. Because each -1 means push, and each positive value, each -1 means drop, each positive value means push. So that means that there is, after this element was added, there was same number of pushes as there was number of pops after it. So the current value is the last element of this on the step. But it would be a squared solution. So now we need to use our segment 3. So we have a balance. If balance in the root is 0, then the stack is currently empty, and we can output -1. And then if it is not, we look at the balance in the right part. If it is positive, more than balance, then we just query return query there. Otherwise, we need to balance And if we are currently in the segment 3 element with a single with array of the length 1, we just return value of this element. So let us write the corresponding function. So we have update. Here we have segment 3 of the form. Plus segment 3, try segment 3. Review and balance. So if it is from so that looks like this. Date, position, and okay, if position from or position 1 and 2 we just return. Otherwise, if value is more than 0, we have 1 to balance. Else, subtract 1 for balance. If it is leaves of the tree, then value this value otherwise, we call update from the left to the left and to the right tree. This is update. And query look like this. Questions about problem C and about integral trees in general. Okay, so today's contest will be actually stage of open cup competition. So I probably will less willing to answer questions about problem statements that are already answered in problem statements itself because of the rules of the open cup competition. Open cup competition is a series of competitions that are open for teams, not only for students but from everyone. But to participate in it is about like 12 or 13 competitions per year, which have some points for each stage. And your total position will be sum of your points, and so on. To participate in this competition, you need some kind of site. To establish a site, someone from university staff or from like someone should write the hub administrator, who will then provide him with login information for participants. They should participate in the single venue, not like from home, but from some university or something. And so it's less prone to cheating, not so much cheating would be. So this currently the competitions go through autumn to spring, so currently we are in the middle of the current edition of the Open Cup, but still you can enter starting from any stage. So I recommend you to contact after this training camp is over. I recommend to contact your university staff and ask to have a site at your university. Because, well, currently almost all top teams from Europe, from Asia compete in this competition. It will be very good for practice, and I recommend to participate after this stage as well. So competition will be as usual 15 minutes, start as usual 15 minutes before 1. I sent the link to login already into the mailing list. So I hope you will enjoy it. If you have any questions that you do not want to ask in public, I can answer them now. Thank you.
Guys?